Welcome, everyone. Today, we're diving into a critical phase of software development, algorithm design and logic planning. Before we write a single line of actual code, we are going to learn how to use Claude as our lead architect to map out our logic perfectly. Let's start with the absolute basics. What is an algorithm? Stripped of the jargon, an algorithm is simply a step-by-step procedure or formula for solving a problem. Think of it like a highly detailed recipe. Before you start chopping ingredients or, in our case, writing code, you need to know exactly what you are building and in what precise order. Algorithm design with Claude involves creating pseudocode, which is essentially plain English code, and mapping it out visually using flowcharts. We do this because jumping straight into coding is a massive trap. It inevitably leads to spaghetti code and missed edge cases. By partnering with Claude during the planning phase, we use its massive reasoning capabilities to lay down a flawless blueprint before a single line of code is compiled. Take a look at this pipeline on the screen. It illustrates our optimal workflow. On the far left, we begin with a raw idea. Instead of jumping straight to the final node code execution, we insert Claude collaboration right in the center. Claude acts as a routing engine, taking your thoughts and splitting them into two vital planning artifacts, pseudocode and flowcharts. Only when these two central nodes are fully reviewed and approved by you do we move to the right, generating flawless code execution. This architecture saves hours of painful debugging later. You might ask, if Claude is so smart, why can't I just tell it to write the whole app at once? Because going from 0 to 100 skips the crucial verification phase. When you plan first, you establish ironclad constraints. Constraints aren't limitations. They provide clarity that helps Claude understand exactly what you need. By separating the planning from the implementing, you drastically reduce the cognitive load on both yourself and the AI. You get to focus purely on the business logic, while the AI maps the steps. As enterprise best practices dictate, we must explore first, then plan, then code. Planning first significantly reduces the risk of the AI hallucinating features you didn't ask for, or missing edge cases that are critical to your application's success. This diagram perfectly contrasts the two approaches to AI-assisted development. On the top path in red, rushing into coding without a plan leads directly to a high hallucination risk and spaghetti code, because Claude tries to guess your ultimate intent while simultaneously worrying about language syntax. The bottom path in green shows our professional method, algorithm planning. By establishing clear boundaries and mapping logic for easier debugging upfront, these paths converge into predictable software. It is a slightly slower start, but a significantly faster and safer finish. If you are using the Claude Code CLI, Anthropic has actually built this exact philosophy directly into the tool via a feature called Plan Mode. What is Plan Mode? It is a specialized, read-only state where Claude explores your files, answers questions, and maps out a strategy without altering a single line of your codebase. You trigger this by using the /plan command, for example, typing /plan fix the authentication bug. During this phase, Claude is highly interactive. It might use an internal tool called Ask User Question to pause its process and gather requirements from you to clarify any ambiguity. This ensures the agent fully understands your environment before it proposes the pseudocode. It's exactly like sending a surveyor to evaluate the land before you start pouring concrete. Let's walk through this state diagram representing the Claude Code execution loop. We initiate in plan mode. If Claude detects missing information, it transitions to the Ask User Question state, halting its progress until you provide clarity. Once the logic is flawlessly mapped, it outputs a detailed plan. Here is your safety gate. The system waits for your approval. Only after you give the green light does it transition into normal mode to implement the code. This state machine guarantees that no unauthorized or misunderstood changes ever hit your disk. Now let's actually craft some pseudocode together. Pseudocode bridges the gap between human thought and machine execution. To get the best results from Claude, we use a technique called chain of thought prompting. This simply asks Claude to explain its reasoning step by step, which is highly effective for breaking down complex problems systematically. We prompt Claude by assigning it a role, like senior architect, and explicitly commanding it not to write actual code. Instead, we ask for a logical breakdown of inputs, operations, and outputs. By doing this, Claude allocates its processing power, its thinking tokens entirely towards solving the logical puzzle, rather than worrying about whether a specific library is imported correctly. This prevents the model from jumping to hasty conclusions. Observe this sequence diagram of our interaction. You, the user, send the prompt requesting pseudocode for an authentication flow. Internally, Claude enters a chain of thought reasoning process. Instead of returning a wall of impenetrable backend code, it streams back a highly readable sequence: validate input, check rate limits, verify hash, issue token. You can read this as a human, instantly spot if check rate limits is in the wrong order, and correct it before any real code is drafted. Once we have our text-based pseudocode, we take it a step further by visualizing it. Why? Because text paragraphs can hide structural flaws, but a visual diagram exposes them instantly. If you have a missing else statement in your logic, a flowchart will show a glaring dead-end arrow. To do this, we simply instruct Claude to convert the approved pseudocode into mermaid.js syntax. Mermaid is a fantastic, markdown-like scripting language that renders complex diagrams dynamically in the browser. Because Claude's training data includes vast amounts of technical documentation and code, it is an absolute master at generating 100% syntactically correct mermaid code. You can paste this generated code into your Markdown files or GitHub readmes to instantly visualize your software's architecture for your entire team. Here is an example of the exact kind of flowchart Claude can generate for you from pseudocode. We start at the top with user login and immediately hit our diamond-shaped decision nodes. Is the input valid? Is the rate limit okay? Notice how the visual branches force us to account for the no scenarios, returning a 400 error or a 429 error. When you generate this with Claude, you are visually verifying that the AI understands exactly how the application should behave under failure conditions, ensuring a robust final product. We have our pseudocode and we have our flowchart. Are we ready to code? Not yet. Now we validate the logic using a meta-prompting loop. This is where we create a feedback cycle, systematically refining the approach. We open a new prompt and tell Claude to act as a ruthless security auditor, tasked with finding 3 ways the current pseudocode could fail or be exploited. This forces Claude into a reflect and select pattern. It critiques its own logic, looking for race conditions, unhandled null values, or security loopholes. Once it identifies these weaknesses, we instruct it to update the pseudocode to patch those holes. We are literally using AI to debug the algorithm before the algorithm even exists in code. Finding an error here costs nothing. Finding it in production is catastrophic. Look at the red security auditor node in our validation cycle. The draft pseudocode enters this node and gets aggressively tested against edge cases. If vulnerabilities are found, taking the yes path, Claude suggests patches and routes the workflow right back to the beginning to rewrite the pseudocode. This iterative loop continues until no vulnerabilities are found, allowing the system to exit safely into the green, finalized algorithm state. It is a brilliant self-healing design mechanism. Let's apply this to a highly critical, real-world use case, a payment gateway migration. Imagine we are moving a massive application from Stripe to a brand new custom payment provider. Writing this code blindly is a recipe for dropped transactions and catastrophic revenue loss. Instead, we instruct Claude to use plan mode to design the algorithm first. Claude proposes a shadow mode deployment in its pseudocode. Live traffic hits the old API to ensure users can buy things, but we asynchronously fire identical requests to the new API to verify data parity in the background. Claude maps out the retry limits, the error handling, and the logging requirements. By architecting this logically first, we guarantee zero downtime during the eventual migration. This diagram is the actual shadow mode architecture Claude would design for you. The checkout request splits. The solid line goes to the primary gateway to return immediate success to the user. Meanwhile, the dashed line represents our asynchronous algorithm testing the new custom gateway. The logic asks, did the new gateway match the old one? If no, it logs a discrepancy alert for the engineering team. This flowchart makes a highly complex, high-risk migration instantly understandable to both developers and business stakeholders. To summarize, treating Claude as a senior architect rather than just an automated code generator will drastically elevate the quality of your software. Always separate your concerns, design the algorithm first, validate it, and only then write the syntax. Take the pseudocode and mermaid diagrams Claude generates and commit them directly into your documentation. They are invaluable assets for your entire team. Remember, it is infinitely cheaper and faster to iterate on a text-based plan than to refactor production code. If you found this architectural deep dive valuable and want to truly master AI-assisted development, please like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Let's build something amazing together. Our final diagram distills the entire philosophy of this session. Algorithm mastery sits at the center. It branches into three non-negotiable pillars. Plan first using pseudocode and flowcharts. Validate aggressively by hunting edge cases through meta-prompting. And finally, execute by generating the actual syntax and testing it. Master this workflow, and you will never stare at a blank code editor in confusion again. Thank you for watching, and see you next time.